Okay, guys, good morning. Are you able to see my PPT presentation slides?
Yes, sir.
Yes.
Yeah. Okay, just to recap last class. I mean, overall, we do recap within 2 to 3 minutes. That will help you to understand because last 4 5 days you don't have a class. I mean, about our DME, I'm saying. So now we first discussed eccentrically loaded joints in shear. Okay, in this case, primary shear, I mean, there are two loads we considered: primary shear, secondary shear. Primary shear is nothing but the direct load due to the direct load acting on the bolt, that is primary shear. Now secondary shear is considered with respect to bending moment, the secondary shear in this case, right? Now, and here we have to first find out the primary shear p prime. P prime is primary shear, secondary shear is p double prime. P prime is a direct shear from the, I mean, with respect to the direct load. Then how many bolts we use, then direct load divided by number of bolts, it will give us the primary shear. Now secondary shear with respect to bending moment, right? Then, I mean, each bolt, what is the secondary shear, we have to find it out. Then that's what we discussed, this formula, we derived that formula: P1 dash, P1 double prime, P2 double prime. Now, this is a secondary shear with respect to bolt 2, with respect to bolt 1. Okay. Now, I mean, once we have found the two shear forces, we have to find out the resultant force in the bolt 1. This is resultant force bolt 1, resultant force bolt 2, like that. Now here I told you that this is the due to primary shear, this one, this is the secondary shear of the bolt 1. Then resultant is a P1 is, sorry, resultant load or resultant force P1 is equal to whole square root of, I mean, P whole square root of P2 minus, right? What is the formula? P2, yeah, actually, I forgot the formula. P2 minus, I mean, P1 dash minus. Can you tell me that, someone? What is the resultant force? Just recap. Anyway, we are not going to spend more time in this. What is the P1? I mean, resultant force at with respect to bolt 1. Formula. I clearly explained that. What is the formula? Anyone? See, you can see here. I mean, this is the P1. I mean, P1 is resultant force with respect to bolt 1. This is nothing but P1 double prime, P1 double prime cos theta minus P1 single prime whole square. That's what we discussed, plus P1 double prime sine theta whole square. Okay, in this case, now the two forces are in, I mean, opposite direction. P1 prime and P1 double prime and P1 prime are double, I mean, opposite direction. Hence, this is a minus. Suppose if you take bolt 2, suppose if I take bolt 2, then P1 and P2 are same direction. Then this is the, I mean, you have to remove this, then put plus sign. Put plus sign. That's all. Here to be 2, here to be 2, here to be 2. Suppose bolt 3, then here what is this? P1, P3 double prime cos theta minus P3 prime whole square plus P3 double prime sine square theta. So that's what we discussed. And then based on these shear forces, then based on where is the maximum shear force? I mean, based on the maximum shear force, we able to find out the, I mean, diameter of the bolt. I mean, this is the case eccentrically loaded shear joint. Okay, now I come to this next one. I mean, this is the steps to be followed for designing the bolt while solving the problem. Okay, now this is the, well, I mean, the arrangement. It not only 4 bolts, it may be a 6 bolts, it may be 8 bolts, depends on applications. We have to use number of bolts. Okay, Now we discussed there some couple of problems in this about that one. Now the second case we discussed eccentric load perpendicular to the axis of the bolt, perpendicular to the axis of the bolt. In this case, earlier case, both are primary prime both. I mean earlier case both loads are shear load, primary shear, secondary shear. Now in this case, one shear load and one, I mean, tensile load is acting. I mean, you may expect this kind of questions in any competitive exam, even our objective also. Here, primary one shear, so shear force, shear load, and tensile load. In this case, now, in this case, now, I mean, the shear load is a direct, the with respect to direct load, P1 P divided by number of bolts. I mean, load acting. The load is acting here now. When the shear load is acting here, sorry, when the load is acting P in offset distance from the bracket frame, then what will happen? The frame going to be, the bracket going to be tilt. I mean, due to tilting effect, the frame, I mean, this is going to be deformation here at the bolt one, because here we are considering the two set of bolts. I mean, the first one is the top one is we are considering, we are notation one, the second bottom there are two bolts are there, we are considering the notation two. When the force is when the force is acting on the opposite distance, then the first set of forces, first set of bolts subjected to tensile. But we already know shear. What is the shear? Shear already we have found it. Then now, when the bolt is, when the frame is, when the bracket is tilting, when the bracket is tilting with respect to point C, because this is a point C, here only no deformation, no displacement. Hence, we are finding the, I mean, we are considering the point C as a reference point. I mean, the taking bending moment with respect to C, we able to find out the force, I mean, the say tensile load acting in the bolt 1 and 2 with respect to bending moment. Now, see here, that's what this is a direct shear with respect to direct load. Now, I mean, here we already know the delta 1. This is a delta 1. I mean, this is the distance C is here. This is the climbing where the tilting going to happen with respect to point C. From that point to bolt 1. This is the bolt 2. This is distance delta 2. If you, I mean, then from this point to this distance is delta 1. Then now P is proportional, delta 1 is proportional to L1, delta 2 is proportional to L2. I mean, we are using this strength of material concept with this one. What is this? I mean, L is proportional to delta. This is L is proportional to delta from this formula. Okay. Now, P is proportional to CL1. P is proportional to CL1. We are using this relations to, I mean, considering this concept, P is proportional to CL1. Here P is not P, here P double prime. Earlier P1 is this is P1 dash and P1 prime, P2 prime are shear load. Now P1 double prime, P2 double prime, we are considering pro is equal to CL1, CL2. Then, I mean, finally we are using the bending moment concept to find out the P1 double prime, P2 double prime, because the bend now in this case the bolt is subjected to tensile. Then P1 double prime, P2 double prime, we can find it out from this concept. Then PL1 P into L1 divided by 2 into L1 squared plus L2 squared. Okay, now see here tensile and shear is playing. Then the corresponding shear load, we able to find out shear stress. We know the tensile load. This is a P1 double prime, P2 double prime. We were able to find out the tensile stress. Then we know now tau and the sigma t. Then we able to find out the maximum shear stress, maximum normal stress. Based on that concept, we are going to designing our the bolt dimension. Okay, see here, this is sigma n. This is a normal, maximum normal or maximum principal stress. Then in this case, and tau max, this is with respect to sigma and tau. So with respect to sigma and tau, we able to find out tau max. From these two relations, we able to find out our dimensions of the bolts. Now, one thing, earlier case, both are shear, primary shear, secondary shear. In this case, shear and tensile. Now, this is the example. and the load is acting here. Now I come to the another case. This is a corresponding problem we discussed. I mean, this is the load is connected bottom side of the frame. This is a bracket. This is the frame. Okay, load is connected. Okay, this is bracket. Now see, I mean here, I mean exactly I would like to show you. Have you understood this how it will be? Shall I show you one example? I mean practically that you can take one book. The book, one book is top side, another book keep it join the another bottom side of the book. Keep the book in vertical in horizontal direction. You join the bracket in bottom of the book. That's what. This is the eccentric load parallel to the axis of the bolt. I mean now the all the forces are parallel to the axis of the bolt. Then in this case, all the bolts are subjected to tensile load only. All the bolts are subjected to tensile load only. I mean, see this, since the bolts are identical, that the tensile force acting in the bolts is a direct tensile. Okay. Now the P, this is now that I mean direct tensile. With respect to bending moment, we are going to find out the another tensile load. I mean that is nothing but the bolt resistive force developed in the bolt. Resistive force developed in the bolt that we are finding with respect to bending calculation, bending moment calculation. Now this is the load. This is a load in the bracket acting P in the distance of L1. In the distance of L1, then we are using this is a PL1. Okay, this is two set of bolts. I mean, the see here. This is a corner now. Now, when the load is acting, this load is acting here. This is the bracket going to be deflect like this. Okay, deflect like this. From this, we able to find out 2P1 because two set of bolts. Then the 2P1 into L1 because the first set bolt is here, sitting here 2 into P1 P double frame L1, and this bolt is sitting here. This another bolt also sitting behind of this. Another bolt is sitting behind of this. Then 2 into P2 double frame into L2. Okay. From this earlier we are considering P1 frame, P1 double frame, P2 double frame is proportional to L1, L2. From these relations, we have found out C1. What is the C value? I mean, once we found that this is a P2 frame and P2 double frame, P1 double frame, what is that? What is the load acting in the bolt? We are able to find out. But where is the maximum load? Maximum load is acting at the P2 double frame. This is here only maximum load is acting in this bolt because this is the farmost distance as compared to P1 as compared to bolt 1 with respect to the clamping. I mean, with respect to the point C, with respect to point C here. With respect to point C, then the delta 1, the bolt 2 is the farmost distance, hence the maximum tensile load is acting here. Hence, directly I'm considering P2 is the direct tensile load. Then, what is the resultant load here? Resultant load in this case, directly summation, principle of superposition here, sum it here. I mean, this is a tensile, direct tensile. This is the tensile with respect to the bending moment. Then directly sum it P1 frame, P2 frame, and P1 double frame. Sorry, P2 single frame and P2 double frame. Sum it, that is a direct tensile load. This is your resultant load acting in the bolt. I mean, with respect to this, we are able to find out the dimensions of the bolt. Okay. Now, up to this, we discussed three cases we discussed. In this case, both loads are in tensile. Both loads are tensile. Please remember. Okay. Now, I come to this last case, eccentric load and circular base. Eccentric load and circular base. See, there's some basic theories. Then we go for the derivation and corresponding to the problems we will discuss. Now, see. Now, see here. I mean, many times a machine component is made with the circular base. This is we are very well known about that, right? Circular base, which is fastened to the structure by means of bolt located on the circumference of the circle. I mean, see here, we are here using it looks like circular flange. Circular flange. This is the frame. This is our frame. In this frame, the circular flange is fixed with the help of the bolt and nut. But the bolt and nuts are located along the circumference, along the pitch circle, along the circumference of the circle, along the circumference of the circle. 4 bolts or 6 bolt or 8 bolts based on how much load is acting. Based on, we have to choose number of bolts and nuts. Okay. Now the see here the flange bearings of the machine tools. I mean, examples are given. Flange bearings of machine tools, one example. Another example, structure of pillar crane, or the example for this type of loading. One is flange flanged bearing of machine tool, an example. The another example is structure of the pillar crane. Structure of the pillar crane. Okay, now you might have been seen, I mean, people are making constructions in two stairs, I mean, single floor or multi staircase buildings, right? In this case, they are using, I mean, pillar crane. The base of the crane is circular base. The base of the crane circular. The base, it will be acting as a flank. That's what. And we are going to see the couple of problems. You can easily understand that time. Okay. The round of flange is flange bearing fashioned by means of the 4 bolts. Here, how many bolts we are using in this arrangement? We are using bolt 1, we are using bolt 2, we are using bolt and nut 3, we are using bolt and nut 4. Okay. Now 4 bolts we have been used in these arrangements. But here also we have to follow the some of the assumptions what we considered previous cases. All the bolts are identical, all the bolts are same material. Okay, identical dimensions. The bearing and structures are rigid. Second assumption. Third assumption, the bolts are not preloaded. I mean, there is no tensile stress due to initial tightening. We are not considering while tightening the bolt, the initial tension may be there. That effect we are not considering in our, I mean, discussion. And the bolts are relieved the shear stress by using dowel pins. Here they are using some dowel pins here for relieving the shear stress. For relieving the shear stress. Okay. Now we come to this further derivation here. Now, I mean, here also we are considering this. I mean, point C. When the load is acting in the flange in the opposite distance L from the frame, then what will happen? I mean, this is a deflection going to happen like this. Okay. Now, I mean, now this is bolt 1. Please listen very carefully here. This is bolt, the distance from the point C to bolt 1, the vertical distance is L1. Now, from the point C to bolt 2 location here, this is L2. I mean, then the vertical distance from point C to, I mean, that the bolt location 3, the distance is L3, this one. Now, similarly, bolt 4, I mean, the distance from point C to bolt 4, this is L4. These are the important information while we are going for designing the bolt. Okay, now, see here also I can consider, I mean, P delta proportional to L1, delta 2 proportional to L2, hence P1 is proportional to L1, P2 proportional L2, P3 proportional L4, L3, P4 proportional L4. Then we are using this concept, we are based on this concept, P1 is equal to CL1, P2 is equal to CL2, P3 is equal to CL3. Now, I mean, take the bending moment with respect to point C now. Take the bending moment with respect to point C, while the load P is acting offset the distance from the frame at a distance L. Now, see here, now the left hand side PL is equal to then 4 loads or 4 bolts are there. Each bolts are located at different distance with respect to the point C. Hence, now here we are taking the bending moment with respect to point C. Bending moment with respect to point C. Hence, P1 L1, P2 L2, because the load P1 L1, this distance already given here. P2 L2 we already know, P3 L3 and P4 L4. This is the P4 L4. From this relation, we are able to find out what is C. Once we know the C, substitute here, then we are going to get, I mean the load P1 at the bolt, the load P2 at the bolt 2, the load P3 at the bolt 3. We able to find out corresponding P4 also we able to find out. I mean this is our load P1 at bolt 1 is equal to P into L1 divided by L1 squared plus L2 squared plus L3 squared plus L4 squared. Now we'll see. Now, I mean, here, I mean, see here, the resisting force, what we are calculating here, while the load P is acting in the offset distance from the frame at the distance of L from the frame, during that time, the resisting force acting on any bolt due to tendency of the bearing of tilt or bracket tilt. I mean, tilting due to tilting effort, the I mean that flange tried to deform or deflect this here. Then during that time, the each bolt tried to resist that resistive force only we are able to find out. I mean the form of P1, P2, P3, P4. Okay. Now this is a P1 we have found. Similarly, you can find it out. Now, if you go for P2, then only this numerator L1 instead of L1 you have to put L2. If you would like to find out P3, instead of L1 you put L3. If you find out P4, instead of L1 you have to put L4. That's all. Now we come to furthermore discussion here because this is circular flange. The circular flange, I mean the diameter of the flange is 2a. I mean the pitch circular flange diameter is 2a here. Okay. Now the pitch circle diameter is 2b here given. I mean, with respect to, we are going to find out that L1, L2, L3 distance now. Now see here, L1 is equal to A minus B cos alpha. L1 is equal to A minus B cos alpha. Sorry, L1 is equal to A minus B cos alpha. How it is? Okay, now see here, this is, now I draw it here. This is the only one thing I draw it, remaining you can understand. This rectangle triangle I'm going to take, this rectangle triangle I'm taking. Now anyway, this distance is given already. This is now A. Flange radius already given 2A. I'm considering one side from here to here A. My bolt is sitting here at the pitch circle diameter. Radius, this is radius B. What is the angle? I mean, this bolt is locating at the angle alpha. This bolt is locating at an angle alpha. See here, then this angle is alpha. This angle is alpha. Now I would like to find out, because this is a point C, right? I mean, this is our flange is sitting here. This is our flange radius. This one is our flange radius. Now I would like to find out, this is my, I mean, this is my B, a radius of the pitch circle. Pitch circle is sitting here. The bolt pitch circle is here. This is a bolt. What is the vertical distance? The bolt 1 is sitting here. The bolt 1 is sitting here. This is L1. Right? Now, what is A here in this case? I can write A is equal to, in this case, L1 plus B into cos alpha. B into cos alpha. Finally, L1 is equal to A minus B cos alpha. A minus B cos alpha. Similarly, you would like to take another bolt here. If I take another bolt here, then now I am taking the another bolt. Now I am taking this bolt now. I mean, this bolt is sitting here. Sorry. This bolt is sitting here. Now, this the rectangle triangle I am taking now. Now, now, this is a bolt sitting here. This is our pitch circle radius, bolt sitting here. Bolt 2 sitting here. Now, this is the alpha. Now, I mean, this is the B. mean pitch circle radius from the center. This is a center. Now what is this distance? This distance is nothing but we already know a. Okay, now we would like to find out this distance. Now, I mean, sorry, one small mistake I have done. Yeah, this is right only. But what is vertical distance? Vertical distance, where is sitting C? See point A also here. Now this is a distance we would like to find out now. This is a distance, correct only. This is a distance we would like to find out. Now the point C is sitting here. This is our required distance. This is L2. L2, right? Now, I mean, point from C to at the center we know A flange radius. Then, I mean, L2 is equal to A plus this distance. What is this distance? I mean, B into sine alpha. B into, this is our radius, pitch radius, B. B into sine alpha. That's all. Sorry. See, now L3. I mean, L3 is sitting below the center line. Then it should be, then similar way you can calculate L3 is equal to A minus B sine alpha. A minus B sine alpha. L4 is sitting here. Then L4 is sitting here. Then that is nothing but L4 is equal to A plus B cos alpha. That's all. So apply this concept. You are going to find out L1, L2, L3, L4. Now, I mean, we already know the tensile load. How much the P1? I mean, we are considering P1. P1 here. Then tensile load acting here. Then substitute in your formula. Then PL is equal to, now instead of L1, L2 squared, L3 squared, I am substituting this. L is equal to A minus B cos alpha. L2 is equal to A plus B cos alpha. We are going to get like this. Then substitute your formula. This is your P1 load is acting. Now, in this case, now I'm not changing the equation, just I'm modifying the equation. I'm not changing the value of the equation, just I'm modifying the equation. I'm introducing numerator 2 and denominator 2. Now this is the same equation. This is same. This equation also same. Now when you introduce 4, when you put here 2 numerator and denominator also 2, then it will become a 4, right? I mean, the 4 is representing number of bolts used in the flange, in the circular base. Now 4 bolts. Now I am considering this is N. N is nothing but number of bolts. I mean, at which case maximum load is acting? At which case maximum load is acting? I mean, the force P1 is maximum value when the cos alpha is minimum value. When the cos alpha minimum value, cos alpha is minus 1. Cos alpha, when it will be minus 1? At cos 180 degree. Cos 180 degree minus cos alpha. Alpha is 180 degree. Then minus 1. Then that time P1 is maximum. Now how can I say that cos alpha minus 180? Now I come to again the same figure. Now I erase these things now. Now see here, the alpha is now here. Now alpha is here. If alpha is 180 degree, alpha is 180 degree. From this figure you can understand. Now alpha is going to be 180 degree, then cos alpha is minus 1. Okay. Now cos alpha minus 1, this will be a maximum load. Yeah, please 1 minute. Just 1 minute. Okay. Now cos alpha is 180 degree. Then in this case, the maximum P1, the force P1 has a maximum value. P1 has maximum value. Now see the, I mean, the bolt 1 will occupy the topmost position. That's what I told you here. I mean, when go here, yeah, see here, the bolt now alpha. Now, when the alpha is here earlier alpha, now when the alpha is the bolt going to be occupied in this position, the bolt is now going to be occupied in this position. At that time only we can say that alpha is 180 degree. When the bolt is occupying this position, the maximum force is acting. Now already we know in the earlier derivation, I mean, which bolt is located farmost distance with respect to point C, that bolt is going to have more load. Now bolt 1 is going to be this location, then obviously maximum load. Obviously maximum load. Now that's what, if you introduce cos alpha 180 degree, alpha is 180 degree, this is the maximum load acting in the bolt. Okay. Now, this equation, I mean, the above equation gives the absolute maximum value of the force acting in any bolts. It should be used for finding out the size of the bolt. It can be used for designing of our bolt. But when the direction of the external force can change, I mean, this case can only valid when the I mean, another way, you may change the bolt angle. I mean, the bolt angle alpha you may change. Otherwise, you can change the load direction. For example, this is I mean, a rotary crane. The crane is rotary crane. Suppose the load is changing from one position to another position, instead of changing the bolt condition, then what will happen? Then at that time only this formula is suitable. Either change the angle of bolt from alpha, I mean alpha earlier less than 40, less than 90. Now from change from this position to 180 degree. Either this case, or when the when the crane is tilting, when the crane is rotating, the force is changing from one position to another position, that time only this formula valid. That time only this formula valid. Whatever we discussed, p max is equal to 2 p of a plus pl of a plus b divided by n into 2a squared b squared. This formula valid with respect. Now the second case, now the bolt, the external force is fixed. The external force is fixed. The crane is not rotated, not rotated. Then in this case, what is this? Now we are going to look that now. Now, I mean, in this case, now for example, come to the same figure here. Now the bolt, now bolt 2 is in beta distance, bolt 1 is sitting in alpha beta angle, bolt 2 is in beta angle, bolt 1 is in alpha angle. Now bolt 1 is alpha angle with respect to the earlier vertical condition, vertical position. Okay. Now in this case, now I can write with respect to bolt and 2, 1 and 2, I can write this is alpha is equal to 180 minus beta. Now alpha is equal to 180 minus beta. Now alpha is equal, I check my pen. Alpha is equal to 180 minus beta. Now what is the beta here? Beta is nothing but, I mean, angle between each bolt. Now beta is same for all bolts. For example, now if I am considering this bolt 45 degree, then this bolt with respect to this angle 45 degree. Right? Now this bolt with respect to this angle 45 degree, with respect to this axis, this bolt with respect to this axis 40 degree. Hence I'm considering my beta is equal to nothing but 1 by 2 into 360 by n. Here n is 4, then when you put n is equal to 4, then beta is equal to 45 degree angle. 45 degree angle. Now, I mean, this is alpha is nothing. Alpha is in generally alpha is 180 minus beta here, 180 minus beta. Then substitute beta value in this equation 1, then we are going to get, I mean, alpha is equal to 180 minus 360 divided by 2n. 360 divided by 2n. Then now substitute our cos alpha. Cos alpha is 180 minus 360 divided by 2n. This is cos 180 minus theta. Cos 180 minus theta is nothing but minus cos theta. Cos 180 minus theta is nothing but minus cos theta. Then cos 360 divided by 2n. Okay. Then This is cos 360 divided by 2n. Finally, our cos alpha is equal to minus cos 180 divided by n. Okay, minus 180 by n. Then substitute our general formula. This is our general formula. Which one we derived? That is our general formula. This is our general formula. Substitute in this. Now, finally, we are going to get 2pl into a plus b cos of 180 by n, this divided by n into 2a plus b square, a square plus b square. Now see here, this is fixed condition that load, that the crane will not rotate and the angle, the bolts are equally transmitted. The bolts are equally stressed or the force are equally transmitted. That's not a very condition. This is then this equation is applicable only when the two bolts are equally stressed, and another way that the external force P is a fixed position. The crane will not rotate. Okay, this is the things we are considering. See here, they have given the direction of the external force P is fixed with respect to bolt, and the number of bolts even number. This equation suitable when the number of bolts are even number. Okay, this is the and the beta angle must be similar to all bolt. That time we have to use this formula. This formula is when the P is changing, then the external direction of the external force is changing. That time we have to use this formula. Formula is 7.16 while changing the load direction of the load. Now I come to the problem. Now see here, a round flange bearing as in figure. This is the figure given. Okay, the is fastened to a machine frame by means of 4 cap screw used, spaced equally on 300 mm pitch circle diameter. The diameter of the flange is 400 mm. Diameter of the flange is 400 mm. The external force is a P is a 25 kilonewton, which is located the distance 150 mm from the frame. This is the distance 150 mm. Okay, now the machine frame. There are 2 dowel pins are used for 2 dowel pins to take the shear load. The cap screw are relieved of all shear force. Determine the size of the cap screws. If the maximum permissible tensile stress of the cap screw, they are given sigma maximum. Sigma maximum is 50 Newton per mm square. Very simple problem. See here, the direction of load is fixed. They already mentioned. It is assumed that the direction of the external force is fixed, and the end cap screws are given. 4 end cap screws are used here. Now we have to use this formula. This is a condition, fixed condition. This is the condition, while force varying condition. This is the change in direction. This formula. Okay, now I use this formula for designing my bolt. Now this is number of bolts given for direct substitution in the formula. They have given everything directly. They have given. See here, pitch circle diameter given, right? 300 mm pitch circle diameter, and diameter of the flange is given. A and B are given. Then A is 200, B is 150. Then substitute here, P is given, and load is acting distance, offset distance given 150 mm. Substitute here. Finally, we are going to find out the load. This is the P1. Now, in this P1, now this is a tensile, permissible tensile is given 50 Newton per mm square. Then, this is the load. Sigma T max is what? Sigma T max is equal to P1 divided by pi by 4 into dc square. From these relations, we are able to find out the core diameter of the bolt. Now, this is the 11.294. From the 11.94. Okay. What is the nominal diameter? Nominal diameter is equal to, DC is equal to, we already know 0.8 into D. From this relation, nominal diameter going to be maximum diameter of the bolt 15 mm. Now I come to the last problem. In this problem, a pillar crane I mean, a pillar crane is shown. See here, the pillar crane is fastened to the foundation by means of six identical bolts. We are using to hold this pillar crane base, the circular base, using 16 identical bolts spaced between the equally 2 meter pitch circle. I mean, 2 meter pitch circle is nothing but B is equal to 2 meter. Okay, the diameter of the filler flange is going to be, I mean, diameter of the filler flange is 2.25 meter. This is 2.25 meter. Okay, BA is given. Now see here that determine the size of the bolt when the 50 kilonewton is acting and the 15 kilonewton is acting at the radius of 7.5 meter. I mean that the crane arm is now here given 7.5 meter from the center point of the base is 7.5 meter. 7.5 meter. Now, I mean, this is given. Now, the maximum permissible tensile stress is given 75 Newton millimeter, 75 Newton per millimeter square. Then we have to find out the diameter of the bolt size, diameter of the bolt. Now, this is a 2A given, sorry, 2A. This is 2A, 2B given. Okay, 2A given, 2B given. This is now which case we are considering now. I mean, now this is this is a not fixed condition. This is not fixed condition. The direction of the force changes while rotating the crane. Now, what is the L here? I mean, here we know, right, what is the L here? The L is from the frame. L is from the frame. They have given total length. I mean, the R is given from the center to where the load P is acting. Then this is nothing but L is equal to R minus A. R minus A. Because we would like to from this frame end. Okay. R minus A. Then this is our L. 6,375. Now, I mean, here the pillar crane rotates about the axis of the axis, and the location of the P will changes, keep on changes. Hence, I'm using the first formula. This formula I'm using to find out my P max. To find out my P max. Now, this is my P max. In this case, substitute the values already given. Then you can go for our design of the bolt. Now, in this case, I mean, Pmax is nothing but sigma t is given. Sigma t into A, I mean, A is nothing but our Pmax. Then sigma t we know. Then area of the bolt is 319.69 mm square. Then this value, where it will match with my standard table, we have to find out. Corresponding notation of the bolt we are going to design, we are going to consider for our design purpose. Now I come to this here. I mean, 319.69 mm square. That is nothing but tensile stress area. That is nothing but tensile stress area of the bolt. I mean, where it is matching. You see here M20 is a 245 mm square. But you see here M24 M24 is 353. This is, I mean close to my value. I can't go for this. Then this is my corresponding diameter. I mean, nominal diameter, minor diameter. I can take for internal threads. I can take for external thread these dimensions. Now, pitch diameter of the bolt I can consider for 22.05. Now, my pitch of the bolt I can consider 3 mm. This is our. And now I can consider now that major diameter. This is a minor diameter. This is a major diameter 24 mm now. For this bolt, the 16 bolt going to have the 16 bolt. Which 16 bolt we are using? Going to that bolt dimension should be followed this. The 16 bolts which one we use, that should be followed these dimensions. Okay. Now finally I come to the conclusion. Now we already discussed, I mean, enough information. Now this is primary shear, secondary shear. Okay. Now here primary shear and tensile. Okay, in this case, in this case, I mean both are tensile. Here, here sigma max and tau max is playing. Here, both are tensile. Then only sigma is playing. Both are tensile. I mean P is equal to P1 frame plus P1 double frame. Both are tensile in this case. Okay. Now the last case here, I mean, while changing the position of the load direction, while the changing the direction of the load, we are assuming this formula for finding the P max acting in the bolt. Now here, then this is the our load is fixed position. For example, the crane problem we discussed. In this case, I mean, this is the maximum load acting in the bolt. Based on that, we have to design our bolt dimensions. This is the four, I mean, 1, 2, 3, 4 cases we discussed. I mean, please be thorough these 4 cases. You may expect any problems in this. And also, there are 2 or 3 questions based my objective questions are possible in this type. Okay, if you have any doubt, please go ahead. Otherwise, I'm going to start the next topic.
Hello, sir.
Yes.
Uh,
Sir, from the case 7.12 and 7.13, if the loads are aligned along the axis of the volt, we have to take the primary and secondary sigma. Otherwise, in 7.13, we can take directly one tensile only.
Yeah, only direct tensile, these two. I mean, direct load. Now, see here, I would like to come one thing. Yeah, this is, yeah, 1 minute. Please stay back. I will show you this. I open my video, I show you that. Are you able to see video?
yes, sir.
Yeah, I take one. This is now see here. This is a vertical frame. This is my book, Advanced Mechanics of Solids book. Okay, now this is a vertical frame. In this vertical frame, okay, now that bracket is connected like this. I make it one bracket like this. Now the bracket is connected like this. Are we able to see here now? Now the bracket is connected like this. See, this is a L bracket, right? Now
Can you
connected like
enlarge your video?
yeah. Now these are 4 bolts are using here. Bolt 1 here, bolt 2 here, bolt 3 here, bolt 4 here. I mean here.
Yes, sir.
Right. Here one bolt, here one bolt. Then here one bolt, here one bolt. Now all bolts are in tensile only, right?
Yes, sir.
Now,
Yes, sir.
now this is now I have taken vertical bracket, but the bracket is now little different dimensions. The bracket is now connected like this. Now like this, the bracket is now like connected like this. The load is acting this corner. What will happen? I mean, obviously, this is the our C point here, tilting point. Now this is a tilting point. How much distance? Now my bracket is like that. Now earlier it was vertical, first case. Now, I mean, now I'm explaining that. Now the bracket is like this. Now the distance between the point C and the load acting point here, then what will happen? This bolt going to have direct tensile load. When the load acting here this much distance, then due to bending, each bolt going to have a direct load. Tensile, I mean, each bolt going to have resisting force. That resisting force we are calculating. So now are you clear? That is also tensile.
Yes, sir.
Okay.
Sir, time up, sir.
Okay, I take attendance, I leave. Okay, guys, and we have to increase the speed. Now, next class, just I show the first slide what I'm going to teach in the next class, then we go for the attendance. We are going to start next class power screws. Yeah, please just go through your Bandari book. You can get some idea. Then we can discuss in the next class. Power screws. Okay, guys. Do you have any doubt in the earlier chapter? Yeah. Roll number 1. Roll number 1. Absent. Roll number 2.
Present, sir.
One absent. 2 present. Roll number 3.
Present, sir.
Roll number 4. Roll number 4 also absent.